Hello friends, welcome back to our channel. Do you know the secret to building a smooth, scalable and high performance application in C#? The answer is C# channels. They may not get the spotlight, but they are a game changer when it comes to efficient task communication. In this video, I am going to demystify C# channels, explain why they are essential for modern applications and walk you through a practical example that will make it all crystal clear. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. What are C# channels? C# channels are like communication pipes that allow different parts of a program to send and receive data in an organized and thread-safe way. Let's imagine you run a restaurant. On one side, you have chefs making bread. They are nothing but the producer, right? On the other side, you have multiple customers, say the consumers, who pick up the bread when it's ready. So how do you efficiently connect the producer with multiple consumers without chaos or confusion? That's where C# channels come to the rescue. Okay, so let's understand it in the programming terminology. So there are three things we need to consider for implementing C# channels. What are those? Number one is the producer. Producer is something like part of your program that sends data into the channel, whereas consumer is another part of your program that receives data from the channel. And channel is nothing but the safe place where data is stored temporarily until consumers picks it up. So the channel ensures that multiple producer and consumers can work simultaneously without interfering with each other. It's all about handling all the behind the scenes work to enable a smooth communication between different parts of your program. This is especially useful in scenarios involving asynchronous programming, where task needs to communicate without waiting for each other to finish. If you see these diagrams on over here, it simply depicts there is a producer and consumer, and in between we have the channel, right? So producer creates data and send it to the channel, and consumer receives the data that was kept at the channel by the producer. So here channel is nothing but the communication pipeline that facilitates send and receive data in an organized and thread-safe way. That's what this diagram depicts that. Okay, so now let's discuss why are C# channel a game changer. There are various reasons behind it. Number one reason is the thread-safe communication. So with this, there is no need to manage complex locking mechanism because channels automatically handle concurrency. Second reason is asynchronous processing. So producer and consumer can work independently without blocking each other. A scalable design. What does it mean? You can easily add more consumers to process tasks faster. And the final one is the cleaner code. So channel provide a structure and declarative approach to communication between threads, avoiding messy code related to queues and thread synchronization. So this makes channel perfect for scenarios like background processing system, task schedulers and many more. Now it's time for an interesting question. How to implement C# channel? So it's very easy. We need to follow just 5 steps. What are those steps? Step number 1. Import the namespace system.threading.channels. So we need to write something like this using system.threading.channels. And why we are importing this namespace? Because our channel class reside in this namespace. So this is the step number 1. Step number 2, set up the channel. As a part of these steps, we create a channel for communication. How we create the channel instance? It's very simple. We write something like this, where bread counter channel is equal to channel.create unbounded string over here. So here what we are doing, we are creating a channel instance that acts like a communication pipeline between producer and consumers. Okay, and here if you notice, I have used this create unbounded method. So this method will create a channel without size limits. It means it can hold as many messages as needed until they are read. Okay, so this is the step number 2. Step number 3, create producer task. So here we need to write the producer task so that in this case our producer will make breads and put them into the channel. So this is the step number 3. Step number 4, create consumer task. In this step we need to set up the consumers. So in our example, multiple consumers can pick up the bread from the counter. Coming to the step number 5, which is running the task, producer task and consumer task. So here what we are doing, we are launching both producer and consumer task. And that's it. This is the way how we are going to implement C# channel. See how simple it is. Okay, let's switch to the Visual Studio and see all these things in action. Alright, so here we are in Visual Studio. Here we are going to see a demo for C# channels where I simulate a restaurant system. In this simulation, a chef prepares different types of bread and a customer picks them up. To show the demo, what I have done, I have created a console application named channels demo that has program.cs file. In the program.cs file, I first imported this namespace system.threading.channels as part of step number 1, since this is where the channel class resides. Next, there is a class named program that contains three static async methods: the main method, the prepare method, and pickup bread method. The main method is the entry point of this application, as we know, right? So first of all, what I'm doing over here, I'm just printing this statement into console window, demo of C# channel, because I'm just giving the demo of C# channels in this program, right? So I'm just printing into the console window with the help of console.writeLine state. Then, as a part of step number 2, what I have done, I created an instance of the unbound channel class by writing the following line. We have written this line, right? Where bread counter channel is equal to channel.create unbounded string. So this line creates a variable named bread counter channel which holds the instance of the unbounded channel. And if you notice over here, I have used this method create unbounded string over here, right? So in this setup, bread counter channel acts as a virtual counter where the chef places bread and customers come to pick it up. This counter ensures that the chef and customers can interact without interfering with each other. Next, as part of step number 3, what I have done, I wrote the chef producer task. Let's review this prepare bread method. It is a static async method that accepts an input parameter of type channel writer string. So this class provides the base functionality for writing to a channel. Inside this method, what I have done, I have defined a string array named bread types containing these values: naan, roti, paratha, kulcha, and bhatura, right? And then there is a for loop. What for loop it does? It just iterates through each bread type. That's what I have written for int I is equal to 0, I less than bread types dot length I plus plus, right? And what I'm doing next statement inside this for loop, I'm just taking the bread type. So based on the index number, I'm picking up the bread type and storing into the string variable named bread over here. Then what I'm doing, I'm just printing this statement into console window. And if you notice over here, I have written bread. So basically I interpreted bread to create a dynamic message over here. So based on the bread type, it is just going to change accordingly, right? So this statement is going to get printed into console window. Then I have issued this statement await counter.write async bread. So with this statement, what actually I am doing, I am saying channel writer to write each bread type to the channel. Essentially what I am doing, simulating placing the bread on the counter level. That's what I have written, place bread on the counter via this state. And then with the help of delay, I am just simulating preparation type of the bread. Okay, so after placing all types of bread on the counter, what this method does, it signals that no more bread will be produced. And how it does so? With the help of this statement, counter.complete method. So this statement is responsible for sending the signal that no more bread will be produced. This is how this chef producer task works. Okay, as a part of step number 4, I created the consumer task. That's why I defined this method, pickup bread method, which is a static async method that accepts two input parameters, channel reader string and customer name. Channel reader string instance, it is responsible for reading from the channel, whereas the customer name, it indicates which customer is picking up the bread. So in this method, what I have done, I synchronized all consumers picking up the bread by using this line, await for each where bread in counter.read all async. So here, await for each, it loops asynchronously through each available bread item, where bread, where it stores the current bread being picked up from the customer. And I have written counter.read all async method. What it does, it reads all available bread until the counter is marked as complete. So this loop ends only when the counter has no more bread left to offer. Inside the loop, what I have done, I wrote this statement to print a message in the console. That's what I have written, console.writeLine customer name consumer picking up bread from the counter. If you notice, customer name and bread I have interpolated. Why? Because I want to print this statement in a dynamic way. And then finally I have added a delay to simulate the time it takes for the customer to pick up the bread. Okay, that's what I have written this statement, await task.delay 500. Finally, as a part of step number 5, in the main method, I launched chef producer task and customer consumer task, right? That's what I have written in step number 5, launching the task. So I started the chef producer task by calling this prepare bread method and passing the channel writer as an argument over here. That's what I have written, bread counter channel.writer. Next, I started the customer consumer task by calling the pickup bread method, and here I am passing two arguments, bread counter channel.reader and customer. So this reader is responsible for reading from the channel, and this is the customer that represents, okay, which customer is going to pick up the bread over here. So basically from these two statements, I am just launching these tasks, and then I wrote this statement, await task.when all chef producer task, customer consumer task. What it does, I'm ensuring that program waits until both the chef producer task and customer consumer task have completed. And once all the tasks are completed, I'm just printing this statement into console window. All customer have been served, right? So that's how the program is structured. Let me execute this program and show the output to you. Okay, so output got appear into this console window. If you see, the first statement got printed demo of CSAP channel, and here chef producer placing naan on the counter, right? So first bread type producer has produced and placed on the counter, and then customer consumer comes up and pick up the naan from the counter. So counter is nothing but the channel over here, right? From where this customer is going to pick it up. Next, chef produces roti and placed on the counter. That's what this statement got printed over here, placing roti on the counter, and then customer consumer comes picking up the roti from the counter, and so on. When all the tasks are complete, this message got printed. All customers have been served. With the help of this demonstration, I tried to show you how two processes, producing and consuming bread, can run simultaneously without interfering with each other, much like a well coordinated way with the help of CSAP channel, right? Okay, so that brings me to end of my session today. To sum up, in this video we learned what CSAP channels are and how to use them in a program for effective task communication. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.